Okay, we have a recording in progress for those who may be joining us, and we are going to start our webinar on home cooling solutions with Alpine Ductless and Tacoma Power, and waiting for a slow start this morning. So
will I see participants in the window, in the normal Zoom window?
If you click on the participant list at the bottom of your menu, and the participants can also do that, they can click on the participant list and see who is presenting or see who are the attendees are.
Got it.
And likewise, you can do the same with your poll or with your chat. So looks like we're going to have a slow start this morning. I will go ahead and introduce our panel, and then we will get started. And if we have more people in a few minutes, we will come back and do some more introductions. So Mark Percy is with us starting on the bottom of the screen, at least my screen, and our little thumbnail sketches. Mark is representing Tacoma Power today, and he will be presenting a few things on this. And Matt Tobin is at the top. Matt is with Alpine Ductless, and he will be doing the presentation. I'm Janda, and I am the coordinator at the EnviroHouse, which is the facility behind me. We will be opening to the public on the 16th with a soft opening, not a whole lot of hurrah about it, just to see how that goes at the beginning after well over 2 years now. And I will be putting information in the chat that will probably not show up in the recorded version, but it is at the slide at the end, and you can copy the chat and get that information out of it if you are seeing that. So with that, I'll let Mark introduce himself first, because I'm introduced him first, and then we can go to Matt and go right into the presentation.
Good morning.
Matt's picture shows Jeanette is her name on the bottom of that, but Matt is not Jeanette.
That's right. I'm logged in under her account.
Yeah. Okay, Mark.
Yeah, I been with Tacoma Power for over 30 years and working in the area for residential homes, trying to make them more energy efficient. We've been doing lots of insulating and replacing windows and replacing heating systems for many years now. We have some really good incentives to help our customers to lighten the load, lighten the cost for them. And so it's still always an exciting thing to see when people do home improvements that not only going to save them money in the long run, but make them more comfortable and make just their life better. That's a good business to be in.
Okay. Matt, you want to introduce yourself? And I'm going to put your contact information in the chat. And I would mention that a lot of people will sign up for these and then indicate that they are going to watch the recorded versions. So if you are not logged in right now and you're planning to watch the recorded version and you have questions, you can follow up with any one of us. Our contact information will be in here. Okay. Okay.
I'm going to pretend we have a full house anyway.
Okay.
I'm Matt Tobin. I'm with Alpine Ductless. I come from 11 years of experience in commercial refrigeration and rebate programs, working for an NGO. And then I've worked with Alpine Ductless for the past 4+ years. So I have some extensive background in refrigeration and rebates, which is a great tie-in with our partners at Tacoma Power. So thanks for the invitation, Mark and Janda. And Janda, would you like me to just roll right into the presentation?
Go right into it.
I think I'm going to do that. Okay. Well, again, thank you all for joining. Today, we're going to be talking about home cooling solutions. So we hear this from customers all the time, and this has been in the news, and you've all seen it. It certainly appears that our area is, if not our planet, is getting warmer. We've all noticed the trends. Everybody's talked about the heat dome that we experienced last year with the unprecedented warm temperatures. And actually, it's been published that 4 of the 5 hottest summers on record occurred in the past 7 years. So it certainly looks like it's a trend, and it is fueling a lot of interest in home air conditioning and cooling. And before you look at spending money on a ductless system or a ducted system, you should consider, and most people have, what your natural cooling options are. Tree shade being one of the, that's been since time immemorial. Tree shade has been one of the best sources of cooling, and it's a carbon negative approach, right? Because it's sequestering carbon for the life of the tree. And unfortunately, the best time to plant a tree was 50 years ago. So if you don't have trees that are shading your house or shading your sun-exposed windows now, it might be a little late to start. And there's no time like the present, right? Other ways to cool that are no cost or low cost. Obviously, you can open windows during cool times and close them when it gets hot. You can reduce the solar loading in your house by keeping drapes closed on the sunny side of the house. And you can use fans, portable or ceiling fans to move the air around the house, which won't reduce the temperature of your house, but it'll make it a little bit more comfortable. Some kind of lower cost or medium cost options would be, install new exterior shades to block sunlight on the windows with sun exposure, and roll away or window type air conditioners are also effective. We don't use whole house fans very much in this area, but that can also be for a pretty moderate climate like ours. It can be a pretty good solution. A whole home fan, since most of you have probably never seen one, is a very high volume fan that's typically located on the top floor of your house. And it's exhausting air through ductwork and then through the roof penetration of your house. So it's basically sucking all that hot air out of your house, and it's exhausting it to the exterior. Even for homes with air conditioning, this is a great way to remove that really hot air and get down to the ambient temperature outside before you turn on your air conditioner. Oops, I'm losing my, there we go. When we talk about portable and window AC units, those can actually be a really good solution. If you've got a small area that you need to cool, you can spend, maybe from $200 to $600 and get a unit into a smaller room. There's some downside associated with them. They're not very energy efficient. You've got an evaporator and a condenser and a compressor all located in one small box, and so they're just not very efficient. They're trading heat with each other. They are relatively inexpensive. They're also really noisy. I mean, if you've noticed, if you've been in a room that's had a window air conditioner in it, you're turning up the television or you're talking louder so that you can carry on a conversation. They can have limited applications. So some windows, they just don't fit. And they can be a little tricky if you've got a 75-pound air conditioner that you're trying to put in a window on an upper floor. Anybody seen the Seinfeld episode? Anyway. They're also relatively expensive to operate, again, related to the inefficiency of the system. And any air conditioning system is going to produce condensate because cold air won't hold as much moisture as warm air. That condensate needs to be put outside the building envelope, and that can be a tricky thing with air conditioners. Some have holding tanks in them, and the system will actually stop air conditioning once the holding tank gets full if it needs to be emptied. And they offer no to very little air filtration. So speaking about about filtration, it's important to consider outdoor air quality. If you're using a natural cooling method like opening a window, then poor air quality from wildfire smoke or poor air quality from allergens like alder bloom and the other trees and flowers that we have bloom around here. If you have allergies, that can all contribute to discomfort and poor indoor air quality. And so during those times when the outdoor air is compromised, you might not be able to open a window to cool your home. And so you need a better solution. So if you're talking about improving your indoor air quality and temperature, you can consider air conditioning. Some advantages besides just making your house more comfortable, air conditioning, an installed air conditioning system is going to offer some air filtration where you can remove particulates like dust from the air. And there are, I'm going to be talking about some other purification solutions. So air conditioning solutions condition and filter the air. And so you can keep those windows and doors closed and hopefully improve the air quality inside your home by reducing allergens and smoke. Ductless air conditioning systems provide nearly continuous filtration because a ductless system runs almost all the time. Even if it's not actively contributing cooling or heating into your room, it's probably going to be cycling the fan over the temperature sensor to see if it needs to come on and start contributing heating or cooling. Because of that, air purification solutions can be great on ductless systems. And there are a couple different kinds of air purifiers that are used. One is a UV light is an effective way to kill viruses and bacteria in the air. And the other is an ionization filter. And the ionization filters work by providing a negative charge to the particulate in the air, causing those particles to stick to each other and then precipitate out. So smoke particles are too small for a typical air filter to filter out, but if you have an ionizing filter, that'll cause those smoke particles to cling to each other, and you'll be able to filter them out, or they'll precipitate out of the air on their own. And as we spoke to on the previous slide, portable AC solutions and window solutions are probably not going to provide much air filtration. So what's the best air conditioning solution? It's probably an installed system. It's probably a ductless system or a ducted system that will continuously condition and circulate filtered air and with the option of adding air purification. And it's funny, I'm a lifelong Pacific Northwest resident. I've lived in Washington my whole life. Growing up, no one had air conditioning, and I lived on Mercer Island, which is we weren't wealthy, but our neighbors were wealthy. Our neighbors didn't have air conditioning either, so it just was really uncommon. Now it's really almost a necessity. In our business, we get a tremendous amount of calls once we get a warm evening. Once you're turning into bed at 10 o'clock at night and it's 85 degrees in your bedroom, that's when the call comes the next day. It's really, for a lot of people, if you're not getting a good night's sleep, you're not well rested, you're not performing at your top level, it's really important to consider things like that. So we say thank a refrigerator. And the reason why we say that is that an air conditioning system is basically a refrigeration system. And the heat pumps that Tacoma Power will provide incentives for are basically a refrigerator that will run in reverse. So it's a refrigerator that will actually heat as well. All these systems, a ductless system, a ducted system, a refrigerator, all work on the refrigeration cycle, which is comprised of a compressor, an evaporator, a condenser, and an expansion valve. So the way that these systems work are, the law of physics is that heat seeks cold. So a ductless heat pump or a heat pump system creates a cold side of a system by evaporating refrigerant inside a sealed system. And it's evaporated by running it through a metering device. So there's an expansion valve, and that creates this cold side of the system. Because heat seeks cold, we create a cold coil. Heat is attracted into that coil. When it goes through that phase change to go from a liquid into a vapor, it takes on energy. So it takes on heat. It then runs that refrigerant to the other side of the system, which is the condenser. And the condenser is the warm side of the system. So when it goes through the condensation cycle, it changes, the refrigerant goes through another phase change where it changes from a vapor and condenses into a liquid. When it does that, it releases the energy, the heat that it took on the evaporation side. And it's doing this cycle continuously, whether you're in heating or cooling mode. And it's just changing the role of the indoor coil and the outdoor coil. So in the wintertime, the condenser is on the inside of your house. In the summertime, the condenser is on the outside of your house. So it's just, and it does that, it achieves that with a reversing valve. It's actually a very simple process. Refrigeration's been around for a long time. I have a 1937 refrigerator in my house right now. Works great. So anyway, the refrigeration cycle has been around for a long time. I think I might have
Went backwards.
I think I went backwards here. So one of the things to consider if you're thinking about air conditioning is efficiency. So when you're considering air conditioning, you should know that the efficiency rating is based on SEER. So SEER stands for Seasonal Energy Efficiency Ratio. SEER is a rating of cooling your home over the entire heating season, or over the entire cooling season, pardon me. I talk about heat for 8 months out of the year, and I talk about cooling the rest of the time. So, so forgive me if I flip those. So seasonal energy efficiency ratio is the mark of efficiency over an entire cooling season. Just like HSPF, which our utilities in this area provide incentives based on high HSPF. That's heating season performance factor. That's the measure of how efficient your system is over an entire heating season. With SEER, the higher the SEER rating, the better. The minimum federal standards have actually gone up. So the minimum federal standards for SEER is actually 14. We've got a slide that's a little bit out of date, and it's going up to 15 next year. And higher efficiency means lower utility bills. So it's something to consider if you're in the market for investing in air conditioning or heat pump system. You should consider the SEER, because that's going to reflect what it costs to operate your system. So first off, we'll look at a central air ducted system. These systems can be really appropriate and economical if you have existing ductwork in your home, and if that existing ductwork does a good job and you don't have untenable, warm spots or cool spots in your house. It's a central system is really, in most cases, is a whole home heating and cooling solution, where there are some central cold air returns, and then there are diffusers or registers throughout your house, typically at least one in every room. And if that works well, a ducted solution can be a good solution for you. The most efficient solutions have inverter-based technology, and that improves the efficiency of the system. An inverter is also called a variable speed drive or a variable frequency drive. And what that allows, instead of a compressor operating at 100%, the system can operate at a fraction of that. So many of these systems can cycle all the way down to about 13% of their total capacity, and they're only providing the amount of cooling or the amount of heat into your home that you need at that moment. They're able to adjust several times per minute based on the so they'll adjust the output several times per minute based on the needs of your house. And I'm sorry, I've got a question here.
Mark had a question about gas.
Question in the chat.
Okay. So, yeah, sorry, I'm going to go back to that. So Mark Percy with TPU was talking about which systems might be appropriate to add central air. So if you have an existing gas furnace in your house, a central air ducted solution could be a good option. I'm speaking specifically about a heat pump. There won't be a utility incentive from any utilities in the Pacific Northwest for adding air conditioning. But if you add a heat pump, then you most likely will be eligible either for a rebate or a loan from Tacoma Power. If you have a gas furnace system, it's very likely that an outdoor unit, the heat pump, could be located on the outside of your house, and a coil could be added to the existing air handler or furnace in your home. But one of the things that you might want to consider is, how old is that system? So there are points of failure in a typical forced air system. A furnace, heat exchangers can fail, fan motors can fail, circuit boards can fail. As your system gets older, those parts can get more difficult to obtain. Fan motors are really no big deal, but circuit boards tend to be proprietary, and manufacturers stop making them typically after 10 years. And so as inventories are depleted, you might not have the ability to service a furnace. So if we add a heat pump coil to an existing furnace, and then your furnace fails, you could end up spending more money than you would if you would have just replaced the entire system outright. So that's something, it's just something to consider, is the age of your existing system and the suitability of your existing ductwork. So our expertise at Alpine Ductless is, can you see my shirt? Alpine Ductless is high efficiency ductless heat pumps. So these really are the most efficient heating and cooling solution available. One of the downsides to a ducted system is that the ductwork that's in a home is responsible for 25 to 30% losses. So out of the cooling or heating that you're paying for, about 70% of that is actually reaching the rooms that you're trying to condition. The rest of that energy is lost in the ductwork. There are two kinds of losses in ductwork. There are pumping losses because we're pushing air through ductwork, right? And then there are radiant losses because oftentimes ductwork is located, is pumping warm air during heating mode through a cold crawl space or through a cold attic. Or you might have ductwork in your attic, and you might have a 140-degree attic that you're trying to push, 60-degree conditioned air through. It's just common sense that that's a source of loss. When you have that heat exchange happening right on your wall with a ductless heat pump, or in your ceiling, or low on your floor, you don't have the losses associated with ductwork. So a high efficiency ductless heat pump can be a great year-round solution. They all include heating and cooling. They provide really consistent temperatures because there's a feedback loop between the indoor unit and the outdoor unit, and they're only contributing the amount of heating or cooling that you need at that moment. Installation tends to be pretty easy. Single room solutions are really simple. Whole home solutions are actually typically a 1 to 2 day installation as well. It's the lowest cost to operate really of any heating and cooling system out there. Long service life. These systems will last for 20 to 30 years. They're exceptionally quiet. So some people have had a heat pump or an air conditioning unit in the past, and they're like, oh, they're so noisy. I need to put it next to my deck. I'm out there having a cup of coffee or a glass of wine. I don't want to have that next to me. These units are typically rated at about 50 decibels versus a typical heat pump or air conditioning unit, central unit on the outside of your house, would typically be rated at about 75 decibels. The human ear hears 10 decibels as a doubling of loudness. So 50 to 60 is twice as loud. 60 to 70 is twice as loud. These operate at about 50. These operate at about 50. Those operate at about 70. So these are really very quiet installations. And if you're interested in ductless, talk to your contractor, see if they can show you a showroom, or if they can show you an existing installation that you can see and hear and feel and that kind of thing. Ductless systems are appropriate for whole homes, or if you just want to cool one room. If you want to cool the heart of your home, the central living room, family room, and you have existing electric heat, Tacoma Power has generous incentives and great loan programs as well. And you've got the ability to add some continuous filtration. Whoops, I just skipped ahead. I hit the wrong button on my, there we go. And okay, so we'll talk about the technology. Again, we talked about a variable speed drive, variable frequency drive, or an inverter. Those are all the same thing. And they kind of work like a car on cruise control. So instead of having foot on the pedal and going up to 75 and then dropping down to 55 and then back up to 75, most people relate because you can hear, if you have cadet heaters, if you have a furnace, you can hear that unit come on and you can hear it shut off again. And the way that a typical system like that works is it'll come on and run at 100%. It'll satisfy the temperature on your thermostat. It'll shut off. It'll let your house lose that heat or gain that heat if you're in air conditioning mode. It'll come back on. It'll run for a few more minutes. It'll shut off again. So it's up and down and up and down. The way that a ductless system works with inverter technology is that it's modulating the amount of heat to match what you need at any given time. And so instead of coming on and turning off and coming on and turning off, it turns on and it just contributes the amount of cooling or the amount of heat that you need at that particular time. We'd already talked about a reversing valve when we talked about the refrigeration cycle. That means these systems can effectively heat and cool your home. It's more efficient than any other HVAC system, whether you're talking about electric heat, whether you're talking about boiler heat, whether you're talking about radiant heat, it's more efficient than any of those. And it's really well suited to our climate. There's a lot of misinformation out there about heat pumps, that you can't use them in the Pacific Northwest because it gets too cold. They don't work below 40 degrees. We hear that all the time. The fact of the matter is that there is a system out there, a ductless heat pump system out there that will take care of your home in all of the weather that we face. So everything that we design will keep your home comfortable at design condition. Design condition in this market is 23 degrees Fahrenheit in heating mode and 90 degrees Fahrenheit in cooling mode. Does it get warmer than 90? Yes, it does. Does it get colder than 23? Sure. And those tend to be transient systems that blow in and blow out, and you'll still have heating engaged during that time, and you'll still have cooling engaged if that's what's necessary. So talk to your contractor about what's appropriate for your house, and you may have the ability to pull out any other heating system. We do it all the time where a customer has cadets or baseboards, and we'll actually disconnect those systems when we install the heat pump, because we know if we've designed that system that they're never going to need those baseboards again. So there's some advantages of this type of heat pump that's associated with a ductless system. These are all called horizontal discharge systems. And if you think about the form factor, kind of the shape and size, think about a suitcase that's too large to carry on at SeaTac. So you've got a good sized suitcase. That's about the size of a typical ductless heat pump system. Maybe in the neighborhood of about 26 to about 36 inches long, if you will, maybe about 2 feet tall, about 24 inches tall, and about 10 inches deep. And they're typically, they're designed to pull air from next to your house and push it out the front. Because they operate continuously on an inverter, again, they're very quiet. These systems, so Tacoma, the city of Tacoma enforces setbacks. So the rule in Tacoma is that if the system sits underneath the overhang of your house, they'll approve it. And these ductless heat pumps will typically be underneath the overhang of your house. If it's a gable end of your house and you don't have an overhang, then there's a standard setback, and any responsible contractor will make sure that you meet those requirements before they sell you a system. So a ductless system has 3 main components. There's something on the inside of your house, something on the outside of your house, and you're controlling it typically with a remote control. I don't like this picture because of the photo in the middle, and that shows a horizontal discharge heat pump with plantings all around that. Please don't do this, folks. It's not good for your energy profile. It's not good for your system. You really want to keep plantings, whether you have a ductless system or a ducted central system. You want to keep plantings at least 2 feet off to the side and a minimum of 3 feet in the front. This isn't a happy place for tender plantings. The air that's coming off of these units is really warm in the summertime, and it's really cold in the wintertime. And it's not a happy place for your plants, and plants can really interfere with the airflow. And it's important that you keep your outdoor unit clear of debris. You don't want to let leaves come in behind these units, because they'll insulate the coil and they'll occlude it. They'll prevent heat exchange in that part of the coil. So it's important to keep your outdoor unit clear. The indoor and outdoor unit that are pictured here are connected by a wire that's called a tray cable. It's a 4-conductor wire and 2 refrigerant lines. And then in addition, a typical installation like this with the wall unit has to get rid of that condensate outside the building envelope. And so again, your contractor will address that during your consultation. The upside of a ductless system is really not very invasive. So there's not duct work that's going to be taking up a bunch of space on your ceiling. It's typically, we just have a 3-inch penetration through an exterior wall, and oftentimes an interior wall, if that's a preferred location, in order to install a ducted system. So one of the things to consider with a ductless heat pump is that these what we call a direct expansion system, where the energy exchange is happening right on your wall or right on your floor or in your ceiling, is very, very efficient, and it offers a lot of flexibility. So The wall units are the most common. So on the far left hand of the slide, those are the most common. Those are the least expensive to place. Tend to have a lot of flexibility. You typically can't put them on top of a window or a door, but you won't be able to center it on a window or door most likely. But you need about 16 inches of wall space to the bottom of the unit. Typically the units are around 12 or 12.5 inches tall. You need a couple inches on top so that you can open up the unit and service it and clean the filters. Floor units, as you'll see in the middle bottom, are a great solution as well. Anybody with mobility issues, I really urge them to consider a floor unit, because you're never going to be on a ladder or on a step stool in order to clean a filter. You just swing the front of the unit open, you pull the filter out, wash it, and put it back in. Ceiling cassettes are a great, really unobtrusive option. The equipment actually is inset into the ceiling and typically blows air in 4 directions. And those are high efficiency. They're typically put towards the center of the room, whereas a wall unit and a floor unit are typically located on the end of a room. Placement of the outdoor unit is important to consider. A couple of things that we look at when we're scoping out an installation for a customer is where is the least expensive option in terms of placement. So if we can reduce the amount of LINESET, the refrigeration lines that connect the indoor and outdoor unit, it's going to be a more efficient application for the customer, and it's going to be less expensive. And it's always important to consider the aesthetic. So typically a lot of people don't want a unit on the front or back of their house. They don't want to detract from the curb appeal in the front. The back might be your outdoor living space. And we get really creative with placement of outdoor units. We put them under decks sometimes. We'll locate them on the exterior of our garage with a wall mount, as you see here on the left-hand side. An important thing to consider if you like this wall mount is that wall mounts are great. They keep the unit off the ground. They typically keep them a little bit cleaner, and they can transfer vibration and noise through a framed wall. So we always make that point with customers that they're nice because they're not going to interfere with getting your garbage can off to the side of your house or getting your lawnmower through there. But there can be some trade-offs. If you have a concrete stem wall, concrete foundation wall, that could be a great solution. It's not generally a great solution for brick. Brick doesn't have enough holding power to hold these units. But if you have a block home or a block wall or a concrete wall, it can be a great place to place a unit. LINESET covers complete the system. So the refrigerant lines, when they're on the exterior of your house, are hidden inside this product called LineHide. And it's a 2-piece plastic channel. It's typically between 3 and about 6 inches wide, depending on how many refrigeration LINESET runs we need to have inside. And that covers up the lines. It gives you a nice finished appearance. And then the next time you paint your home, you can paint the LINESET. It's not going to disappear, but it really minimizes the appearance. The other thing that we try to do, and any good ductless contractor is going to do, is try to minimize the appearance of the LINESET on the outside of your house. Sometimes we'll run it up against an architectural element like a belly band or a corner board, and really minimize the appearance of the unit on the outside of the house. Also, any ductless specialist can look at interior wall options where LINESET is routed inside a stud cavity or inside a closet or inside a garage or maybe a laundry room, that will give you some options for heating and cooling on the inside of your house without detracting from the outside of your house. So we always talk about the relative cost of air conditioning, and it's less expensive than you might think. So TPU does a great job by providing rebates of $500 or $1,000, depending on the type of system that you're looking for and the type of existing heating that you have. They also have some very generous, there's my word, low-cost loans. So typically loans are available for $4,000 or $10,000, depending on your application. And if you qualify under low income guidelines, you might even be eligible for a deferred loan where you don't need to make any payment on the system at all unless the home is sold or refinanced. The cost of a ducted system is generally higher If you definitely higher if you don't have existing ductwork in the home. If you do have existing ductwork, then a ducted or a central system can be a relatively economical option. Multi-zone systems, as we'd provide with a ductless, as we're capable of providing with a ductless system, usually means one heat pump on the inside of your house and then more than one unit on the, one heat pump on the outside of your house and more than one heating and cooling unit on the inside of your house. Those tend to be a little bit less expensive than a comprehensive ducted system. And they give you the flexibility of running multiple zones. So it's very typical. You know, we've got a home with 4 zones installed, maybe the central living space, living room, family room, kitchen, and 3 bedrooms. A kid goes off to college, you turn that system off. You're no longer using, 15 or 20% of the capacity of the system. You're no longer heating and cooling a room that's not being used. And that can be a real advantage. Single zone systems are probably the most popular. Well, they are not probably, they are the most popular system that we sell. That's with one heat pump on the outside of your house and one indoor unit. That can be a really economical option. After rebates from Tacoma Power, you might be able to get into a system for around $5,000. It typically costs a lot less to cool a home than it does to heat a home. That's on a per month basis. Typically, an air conditioning system would only be running between maybe 11 o'clock in the morning and maybe 9 o'clock at night on the warm part of the summer, versus a heating system that typically is running for close to 7 or 8 months out of the year. And if you look at a high efficiency system, so a system that's rated with a high SEER in the case of air conditioning and the high HSPF in the case of a heat pump, then you're going to end up with lower monthly utility bills. Most commonly for people that switch from zonal electric heat, like a cadet heater, a wall heater, or a baseboard, typically the report that we hear from them is during the peak heating season, they see reductions of about 50% in their overall heating bill. So there really is an economic case to be made for a heat pump system. Tacoma Power is nice enough to share this slide with us. So this is a cost comparison. I know we're talking about air conditioning, but we're talking about what it costs to heat your home, because that's what you're doing for about 7 months out of the year. And you can see the most common that we see in this market are an electric furnace, which at $31.73 for 1 million BTUs versus about $8.53 for a ductless heat pump is really significant differential. So there really are some savings to be seen by moving to a more efficient heating option. This is a slide that one of our customers put together for us that showed actual plotting of their kilowatt usage year over year when they had an electric furnace, and then they switched to a ductless heat pump. So again, can be some really, really large reductions. The Tacoma heat pump program specifically is that ductless heat pumps have available a $500 rebate if you're currently heating with electricity, or a $4,000 loan. And if you're heating your entire home, and then you may be eligible for a $10,000 loan. Both of those loans are 0 interest loans. So that's a really, really generous program. And again, Tacoma Power, if you might meet low income standards, they may have a deferred loan available for you as well. A central heat pump would likely be eligible for a $1,000 rebate if you're currently using electric heat, or up to a $10,000 0 interest loan if you'd like the loan option. You have to be a Tacoma Power customer. If you're using natural gas to heat your home now, you'd have to talk to your contractor consultant and see what you're eligible for. Tacoma Power requires that we have some expertise in their program. So your contractor should be able to answer all those questions for you. You want to check or have your contractor check the program requirements and the specifications and make sure that the system is going to be suitable for your house and that it's going to be eligible for rebates. So one word about warranties. Don't buy a brand that doesn't have a warranty. Typically, the length of the warranty especially on parts, is directly related to the amount of experience that your contractor has. The most experienced contractors for the major brands are going to be able to offer a 12-year warranty on parts. Labor warranties are typically an option that's extended by your contractor. So you should talk to them about what an extended warranty costs. There's oftentimes some contractors include extended warranties with every purchase. And we actually offer, Alpine Ductless actually offers a 12-year warranty on parts and labor. So that's some significant peace of mind that you're not paying extra for. So that's an important thing to discuss with your contractor as well. And I think we've come to the end of the presentation. Or if there's any questions, you feel free to share those on chat.
I am not seeing any questions coming in. We have pretty low attendance this morning, but I think people will check in and get our recorded version. I am putting in the chat, if anyone is in here and wants to copy this, I've added the contact information at the beginning, information about the residential contractors, and that information will be on the upcoming slide, I think, the last slide on resources. And I'm including a link on how to register for upcoming workshops. We have one coming up on the 21st, I think it is, on the 18th, on weeds and pests with non-toxic solutions. And I have also included, oops, I put that in there twice because it didn't copy out. Okay, well, let me add the other one then. There's a link that I intended to have in there on how to view recorded webinars. So this will be up online probably in about a week, depending on our media department's time to get it up. And you can come back and view it and follow up with Alpine Ductless folks on making appointments or having questions answered. And Mark, did you have anything else you wanted to add?
Did you want to go ahead and put that resources slide up?
Get rid of it.
There we go. I tried clicking through. I'm sorry about that, Mark. I tried clicking through to that before and it wasn't coming up for me. So
okay,
not a problem.
That will be. And then I did put the information in about the shade tree program because I believe you can sign up now. The program starts where you can begin to get your trees in October 1st, because we don't want you buying trees and planting them in the heat of the summer when they're not going to survive. As was mentioned earlier, you can get $30 off per tree, up to 3 trees. That's a one-time use. So if you think you're going to go in and buy one today and then maybe one more in a couple weeks or maybe in another month, you won't get the extended $30 off. You have to do them all at one time. So there's that information. And again, I thank Alpine Ductless for presenting today. And you can reach out to Matt or call the number on the screen if you want to make an appointment and go forward. Do you guys have anything else to add?
I would just say thank you to the City of Tacoma and Tacoma Power for being a great partner.
Thank you. Okay, if there's nothing else, if you guys want to do a recap follow-up, I created another short webinar. I can just send you links, or if you don't have any questions, then we're done.
Okay.
All right, great.
Do you want me to send those or not?
So the link to a postmortem, I'm happy to do that. Do you each have another couple minutes so you can offer some input?
Okay.
Sure.
Okay. Thank you, everyone. And I'm going to end the webinar and I will see you all in a few minutes.
Great, thank you.